Let's talk about the remainder theorem. So I'm going to talk about f of x equals 4x cubed minus 7x squared plus 2x minus 4. And I'm going to use the remainder theorem to evaluate f of 1. Now, of course, we could just plug in x equals 1, and it wouldn't be that bad algebraically, but this is going to be a nice warm-up example for how we use this. So I'm going to take f of x, and I'm going to divide by x minus 1. And why I'm going to do that should hopefully make sense here in a minute. So if I'm going to do that, I'll do synthetic division. So I have a 4x cubed minus 7x squared plus 2x minus 4. And then the thing that goes up in the box is going to be the 1. Or in other words, if you're trying to find f of 1, 1 is going to be what goes up in the box. Drop down the 4, multiply by the thing in the box. 4 times 1 is 4. Add the column. Negative 7 plus 4 is a negative 3. Negative 3 times 1 is a negative 3. 2 plus a negative 3 is a negative 1, and a negative 1 times 1 is a negative 1. So I get negative 5 when all is said and done. What this means is I had f of x was equal to 4x cubed minus 7x squared plus 2x minus 4. We now know that f of x is also equal to, well, I divided by x minus 1, so there's my divisor, and then the coefficients on the following quadratic are 4x squared minus 3x minus 1, and then I had a remainder of 5. So looking at this new version, if you plug in 1 into here, you'll get a 1 minus 1 times a 4 times 1 squared minus 3 times 1 minus 1 minus 5. And I really didn't need to write out any of this 4 minus 3 minus 1 because check out this. 1 minus 1 is 0. 0 times I don't care is 0. So in the end, I get 0 times something, which gives me 0. And then minus 5, so I get a negative 5 overall. So the remainder theorem says if you want to evaluate f at 1 in this case, we'll then divide by x minus 1, and your remainder is the value negative 5, which we can see if we just plug that in the original, I get 4 minus 7 plus 2 minus 4. That gives me negative 5. Again, you'd probably just plug in x equals 1 on that example, but if you wanted to find, say, f of 5 for f of x is equal to x to the 5th minus 24 x cubed minus 10x plus 3. I don't know about you, but I don't know what 5 to the 5th is off the top of my head, so that would take me some serious work to figure it out. So I'm going to go with the remainder theorem. So let's do synthetic division. So I have a 1x to the 5th. I do not have any x to the 4th, so I got to put a 0 placeholder there. I have a minus 24x cubed. I don't have any x squared, so again, 0 placeholder, minus 10x, and a plus 3. And then I want to find f of 5, so 5 is going to be what goes up in the box. Drop down the 1. 1 times 5 is 5. 0 plus 5 is 5. 5 times 5 is 25. Negative 24 plus 25 is 1. 1 times 5 is 5. 0 plus 5 is 5. 5 times 5 is 25. Negative 10 plus 25 is 15. And here's the first one that's going to stretch me a little bit. 5 times 15. 15 times 2 is 30. 60. 75 is what I got. And you can do that off on the side too if you want. No big deal. So 75 plus 3 gives me 78. So again, if you wanted to, 15 times 5, 25, 75. Yep, okay, so I got 75. So this was probably the trickiest part of this one, and if you have to do the work off on the side, that's totally fine, but it was a lot easier than trying to do 5 times 5 times 5 times 5 times 5 to just get x to the 5th, much less any of the other things going on. So what this means is that my f of x is equal to x minus 5, because I was dividing by x minus 5, times, see, that was a 5th degree polynomial, so this will be a 4th, so I'll have a 1x to the 4th, plus 5x cubed, plus x squared, plus 5x plus 15, and then plus 78 is my remainder. So if I evaluate this thing at f of 5, you'll see if I plug in 5 here, this is 0, so 0 times, who cares, it's 0, plus 78 gives me 78. So I quickly know that f of 5 is 78 in an easier fashion.